All right. We're going to get to it. And today's lesson is an interesting one. If I'm being honest with you guys, which I try never to do, but here's a moment. This is a topic that you didn't used to see in grade 9. In fact, we used to see a little bit of this in grade 10 and a little bit in grade 11. They've moved it down to grade 9, and I think that's a good idea. I think it's a good decision. But I'll tell you right now, this one can be one of the trickier ones, and it can be one of the ones that just requires a bit more concentration. So I'm going to ask, I ask this every day, but in particular today, let's keep chatter to a minimum, let's keep focus, because this is a topic that will probably confuse some of you. And that's okay, but everything is more confusing if it's hard to focus. Does that make sense? So let's keep focused here. This is going to be a chance for us to demonstrate our maturity. All right. So really quickly remind me, if I had 3 to the exponent 5, what does that actually mean? What is that telling me to do? Yeah.
3 times 3 times 2 times 2 times 3.
Good. 3 times 3 times 3 times 3 times 3. How did I know when to stop doing that? Yeah, this means multiply 3 by itself 5 times. Can somebody remind me what we call this? 3 to the power of 5. Not scientific notation is a very particular one. What do we always use as the base in scientific notation?
10.
We use 10 every time, right? But that's an example of this. But this wouldn't be scientific notation because the base is 3. But it's the same idea. We call this and you use the word, a power. And remind me, in a power, we have 2 components to the power. We have this number here and that number there. What do we call those? Do you remember? Just because these are words that are going to come up. Good. Which is which?
The base is the 3 and the 5 is the 3.
Great. And what this means is that we're going to take the base, in this case 3, and we're going to multiply it by itself however many times the power tells us to. And in this case, it says take the base of 3 and multiply by itself 5 times. Oh, I said power twice, but what should I have written up here? Exponents. Sorry about that. It begins. My clumsy teaching begins, and we're only like 2 minutes in. All right. So there we go. We take some base, we put to some exponent. And if I wanted to evaluate this, I could put it in my calculator. I could put it this way, or I could put it that way, but I don't actually want to evaluate it. I want to focus on this relationship because today we're going to work with operations of powers, by which I mean, what if we take a power and multiply it by another power? And after we're done with multiplication, what do you think we might do? Yeah, we'll look at some of the operations we can do with powers. Multiplication, division. We're actually not going to get into addition and subtraction today, but we will later. So what does this really mean? Well, I want to take the same kind of approach we took up there. Here we're doing 4 to the exponent 3, and we're multiplying it by 4 to the exponent 5. Or 4 to the power of 3 times 4 to the power of 5. What does that really mean? So remind me again, what does 4 to the exponent 3 really mean?
It does 4 by itself 3 times.
Okay, so 4 times 4 times 4, that's what 4 to the power of 3 means. And then we're going to take that whole thing and multiply it by 4 to the power of 5. And what does that mean?
4 multiplied by itself 5 times.
Yeah, so 4 times 4 times 4 times 4 times 4. Now, do I want to write this out in full form like that every time? No, that seems like an easy way to make some mistakes. But I want you to take a good look at this. Because I don't want to tell you the rule for what happens when we multiply powers. I want you to take a good look at this. Is there a better way I could write that answer? So I'm going to write it without the highlighting now. You're good. Just hold up for a second. You're good. So if I do it without the highlighting, that might help us see a better way to write this. What would be a better way to write that? Because that sucks. That's miserable, right? Can I say sucks? I shouldn't say sucks. That is unpleasant. What is it?
4 to the power of 7.
Let's count. 1, 2, 3, 4, 5, 6, 7, 8. I get 8 of them. Okay, so 4 to the power of 8. Cool. Now, we could do this every time. If we get a powers question like this, we could just expand it out so it's really big, and then we could count, and then we could put it back into an exponent. But I wonder if you notice something here. What do you notice?
We can just add the powers.
If you look here, this is saying multiply 4 together 3 times, and this is saying multiply 4 together 5 times. Well, all together, how many times does that want us to multiply 4 together then? 8 times. So when we multiply exponents, if the bases are the same, we can just add the exponents. If the bases are the same, we can add the exponents. Because if you think of what an exponent actually means, the first one is saying multiply 4 together 3 times. The next one is saying multiply 4 together 5 times. And if you put those two things together, 3 times and then 5 times more is 8 times altogether. So the rule then is, as long as the bases are the same, we can add exponents when multiplying powers. And I kind of want to do an example and a non-example, one that would work and one that doesn't. So let's do here one that works. Somebody give me a base. 3 it is. Somebody give me an exponent. 3 to the 4. We're going to multiply that by, and for this to work, what has to be true about the next base? Has to be 3 as well. And give me another power. 8. And this would be what? This says multiply 3 together 4 times. This says multiply 3 together 8 times. Altogether, we're multiplying 3 together
12.
Yeah, and I'm actually going to show the math. Very good. This one works. That's an example of a good one. What does not work? And I think sometimes this is helpful, by the way. When you learn a rule, it's good to quickly start thinking, when can I use this? And almost as importantly, when shouldn't I use this? When doesn't this work? If I had 5 to the 4 times 9 to the 8, can I simplify that? Can I work with that? There's no way to simplify this. And the reason there's no way to simplify this is because the bases aren't the same. This says multiply 5 by itself 4 times. 5 times 5 times 5. And man, I'm really about to regret the exponent I picked here, but that's okay. I'm going to do it because I care about you guys. This is my commitment to your education. And this says 9 times 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 9. Can we make this into a single exponent? No, if I did, it would just get me back to 5 to the 4 and 9 to the 8. Does that make sense? So when can we use this rule? We can use this rule when the bases are the same. We can't use it when the bases aren't the same. All right? A good reminder. So we've got some practice here. Let's do the first one together, just to make sure we're all on the same page. And then I'm going to ask you guys to do these, and I'll walk around and say encouraging things, like, good job. This first one, what would that work out to be? Close?
8.
Very good. And how would I do that? I'd say 2, and what are the 2 exponents I'm putting together? 3 and 5. And that's going to give me a total of 2 to the exponent 8. Very good. Probably shouldn't use a big red highlighter there. Be a little aggressive. Yeah.
We're supposed to do the 10 to the power of 6 times 10.
Ah.
Yeah.
For now, that's a great question. I want you to think about, do your best, and we'll take it up. But that's a great question, perfect question, and I'm going to give you the very annoying teacher answer of try to figure it out. And I promise we'll take it up. I have faith in you. Yes, you may.
So if you were to write that, it would be 10 times 10 times 6 times,
By the way,
and then times 10
I
again.
meant to give these to you like, well, Monday after you volunteered for us at the 60th anniversary thing. So sorry that's like that.
Oh, Mr. Orlando.
She's got to look for it.
Do I get your ish for that moment? That's Mr. Orlando.
Mr.
Yes.
Orlando,
What?
I did not understand this.
That's okay. Talk about it tomorrow. Well, let me ask you, Canadian to US dollars. So, this is telling you, in 1 year, if you had $1 Canadian, in January, how much was that with US? Oh, righto. Oh, I see, it was about 78 cents. Amazing.
On Uno, you said.
He's working a restaurant, and in the morning we would pick an accent of the day, and we had to try to remember and not forget to use that accent all day while serving. It was fun. Good. Not really. I mean, if you're feeling confident, if you're feeling bold, I'll get some help. I do are bold. I don't mind it. Anyway.
What does that say? I cannot read that.
Do you not read cursive? Or just my cursive?
I can
Just my cursive?
Yeah,
I'm
your
messy.
cursive is terrible.
Hey, I'm doing my best.
When I write cursive, I write my ends like singular, like I write it all weird.
Like that? Oh. Like just like that, and then you keep going? So would it be like that?
It's basically that.
I respect that.
Like a capital, though.
There you go. Oh, you do like...
Yeah, well,
I'm going to argue that might not be cursive. That's-
well, it's kind
that
of
is...
together. I write halfway in like normal, and then I start writing in cursive at the end of the word.
Or I'll do it in the middle.
Battery's loud.
What's 10 to the power of 2?
100.
This is how I prove.
Oh, yeah, I
get
know.
Okay, let's take a look.
So 10 to the power of 1 is just 10.
Okay, look here. Shh. I'm sorry I have to plug in. Hopefully my battery will recharge quickly. I forgot to plug it in last night. Whoa. Oh, hello, SD card. Okay. So, if we wanted to... If I wanted to write this out in full, I could. This one's not too miserable. So I could have said 3 to the 2 is 3 times 3. And I could have said that 3 to the 3 is what?
3 times
3 times 3 times 3 for a total of...
27.
I mean, first of all, no. But second of all...
3 to the power of 5.
Okay, shh. But do I want to do that every time?
No.
So what's a better way to approach this is to say this first one is 3 to the exponent of 2, which means multiply 3 by itself twice. And then we also want to multiply it by itself 3 times for a total of 5 times. And I would skip this step because it's long and drawn out. And you're likely to make a mistake. Very easy to make a mistake. Maybe not with 2 and 3, but what about this? Easy to make a mistake?
Yep.
Yes.
Sure. Now, I am going to draw this one out just once because otherwise, here's what I'm a little worried about. What do you think the most common mistake is here?
10 to the power of 6.
Yeah, because you could say 10 to the power of 6. And then you could say this next one, doesn't have an exponent. And in math, we have a number for not having something. It is
0.
Yeah. And listen, don't write this. Look at me. Everyone's hands up. Zombie hands, go. Don't write this. This would be a logical mistake to make, wouldn't it? To say there's no exponent there, so it doesn't change. But
There's a 1.
you're right. But if we look at this, it's saying 10 times 10 times 10 times 10 times 10 times 10. Is that 6? 1, 2, 3, 4, 5. Yep. And then times 10. Okay, so if we don't write an exponent, that doesn't actually mean don't multiply this. Rather, it just means multiply it by itself 1 time. An unwritten exponent is actually the exponent 1. Okay, so this would actually total to 10 to the
7.
power of 7. Is that worth making a note of?
Maybe.
I certainly think so. If a number has no exponent, written, its exponent is 1. This is a thing that is often forgotten. Oh my goodness. Easy mistake to make. But again, if you think about it, it makes sense because an exponent means how many times am I multiplying by this? And if you're just multiplying by 10, how many times are you multiplying by 10?
1.
Once. Makes sense, right? And why don't we write it? Well, because then we would have to write every single number we ever write with an exponent of 1 above it, which you could do. How old are you? 39 to the exponent of 1? Clumsy, right? Isn't that weird? What did you got on the test? 84.5 to the power of 1. See what I mean? It's a little unnecessary. Does that make sense? But that's what an exponent of 1 would mean. It would mean multiply by this number how many times? Once. So if you see multiplying by a number, in your head you can always think, oh yeah, if I need an exponent there, the exponent there is 1. By the way, we do this in language all the time. If you have 5 cats at home, you'll say I have 5 cats. Also, that's too many cats. Listen, I like cats, but it's important to know that they're godless killing machines. And listen, all I'm saying is this: like,
I had 21.
when a
so
dog
that's
like
disrespectful.
when a dog like comes up to you and like nibbles at you, it's because it's being playful. When your cat comes up and like nibbles at you, it's because it's trying to eat you. And if its mouth was big enough, it would eat you. And that's all I'm saying is that's the difference.
I'm
Sorry?
not very sure about that either.
Listen. Yeah, I'm just telling you. Cats are godless killing machines, and as long as you know that, they're lovely pets. But like, if your house was on fire, your dog would come like nuzzle you and nudge you and like drag you out of there or die trying. Your cat would just be like, see ya. That guy down the road will give me food, I'm confident. Like, it's just different. It's a different relationship. That's all I'm saying. And so with cats, I always think, what is the number of cats where they could outpower me? I think 5 is getting there. I think by 5 cats they could take me. And so I don't want that many cats. I want to know that I'm safe. That's all I'm saying.
I had 21
Anyway.
and they did not eat me.
That's a thing. I have questions about that, and we'll save it. Okay.
Yes, very much.
Can I give you 2 more minutes to get this table all done? 2 more minutes? All right. Get it done. If you already have it done, golden. If you're confident in one, come put it up here. You'll have to come to my desk. Sorry, because my battery's low. All right, get on it. We need. I want you
Let's do it together.
Okay.
We'll do one together. We're going to use 2 brain powers for one.
All right. However, will you keep math and that lovely accent in your brain at the same time? I just don't know.
We've already struggled.
That's a lot. Well, listen, sit in the chair. Sit in the chair. Now pretend it's paper. Put your palm on it. Slow down. Time. Right naturally.
It's like an ornament to a Christmas tree. Yeah.
There you go. That's much better. And yeah, getting in that habit of showing that middle step. I know if you're really confident with
Will I
this,
show
you
you the
feel like
step?
that's wasting time.
Sure.
That's gonna prevent you
Let's
making
go.
mistakes, I promise.
Okay. Ah. Oh.
Oopsies. I moved the desk.
Oh, what? What in the world? What in the world?
Does anyone do the like McDonald's Monopoly thing? Because I do not. Anyone want these?
No.
Yeah, they come go.
Max, do you even do it? Are you sure? That sounds like you don't.
Yeah.
No.
All right, can we take a look at these? N to the power of 3 times n to the 7. Now there's no number here, but that's okay. This means multiply n by itself 1, 2, 3 times. And this means multiply n by itself 1, 2, 3, 4, 5, 6, 7 times. All together, how many times are we multiplying n by itself? 3 plus 7 is 10. Or possibly e plus z equals 18. Something like that. Good. Okay, I don't like the circle. There we go.
That's disrespectful.
I'm okay with that. Here we're being told multiply x by itself 4 times, then multiply x by itself 2 times. Altogether, how many times is that?
60.
Cool. Now, there's one thing I want to note here that, listen, when we write this middle step, this isn't actually how we want to write it. And that's okay. I'm glad someone did this. I always hope someone does this so we can just talk about how we write it. This means something different. And we'll talk about adding powers in a bit. But when you write it out, make sure what we're saying is we have the base and it's the exponents we're adding together. Like that. Does that make sense? Very good. And then this last one, I was worried if somebody would find this intimidating, right? Because now we don't have just 2 of these, we have 3. But is that fine? Yeah, of course it's fine. So this says multiply p by itself 4 times, then 3 more times, then 4 more times. And 4 times and 3 times is? No, 4 times and 3 times is? And 4 more is?
11.
Good.
I did that one.
Very good. You did a lovely job, and it's nice and neat. I'm going to change the color on these. That's better. Okay, great. You guys have done lovely. That's wonderful. Hopefully I got a bit of battery here because I want to stand up for this.
Past 5 minutes.
Now, Now, I want to take a look at this. And before we do this, I just want to quickly ask you something. And you don't have to write this. Just look. What is 3 divided by 3?
1.
What is 85 divided by 85?
1.
What's 9 divided by 9?
No, 1.
What is x divided by x?
1.
What is 274.58 divided by 274.58?
1.
So what? Because I said to. Ugh. No, why am I doing this? What rule do we take away from this? It's a perfect question, by the way.
1.
What are we taking this? 1. Okay, listen, if what you took from this is the answer to any question is 1, no, because what's 2 plus 4?
1.
6, all right? No. What can we take away from this? What rule are we going to remember here that's important?
If you divide a number by itself, it's 1.
Anything divided by itself is 1. Okay, shh. That's important because we're going to use this fact over here. Right? You don't have to write this, though if you want to scribble it in the corner, that might be helpful for you. Even if you just scribble this. In fact, let's scribble that.
You just said you didn't like
I changed my mind. How's that? Yeah, I'm allowed. I'll do what I like. Reminder. Anything divided by itself is 1. Doesn't matter what X is. If you have $54 and you divide it among 54 people, everyone gets a buck. You got $200 and 200 people, everybody gets a buck. All right, cool. Look here. Shh. Let's consider this and what this really means. Well, what does the top of this mean?
3 times
Just the top. Don't worry about the bottom yet. We'll get there.
3 times 3, 5 times.
3, 1 of them, 2 of them, 3 of them, 4 of them, 5 of them. All right. Now this whole thing is being divided by the bottom of this fraction. What do we call the bottom of a fraction, by the way? Denominator. Good. What's the denominator of this fraction?
3 times 3 times 3.
Okay. Now, all we have here is multiplying and dividing. But multiplying and dividing you can do in any order you want, which means if I want to, instead of going 3 times 3 times 3 times 3 times 3 divided by 3 divided by 3 divided by 3, I could say 3 divided by 3. But what's 3 divided by 3 equal? 1. So I could say 3 divided by 3, and that just equals 1 times. Does that make sense? But does multiplying something by 1 change it?
No.
So it's almost like those just disappear. Does that make sense? And then I could do 3 divided by 3, but what does that equal?
1.
1. And then I could do, run out of colors here, 3 divided by 3, and what does that equal? 1. And what do I end up with? This 3's been reduced to 1. This 3's been reduced to 1. This 3's been reduced to 1. There's no 3's left on the bottom. And what am I left with?
1.
What's still up here? 3 times 3. Is it being divided by anything?
No.
If it's not being divided by anything, do I have to draw a division?
No.
No. And what's a better way of writing that?
3 to exponent 2.
So, that's a bit of a leap. But in math, we'll actually do this a lot, especially, maybe even more than in math. Man, if you take chemistry or physics or any of the kind of physical sciences that use a lot of math, this thing where something appears on the top of the fraction and the bottom of a fraction, and all of the operations of multiplication and division, the fact that we're able to cancel them like that, canceling something in a fraction is a really important math skill. It comes up a lot. Where if all we're doing is multiplying and dividing, something divided by itself just equals 1. And the truth is, I wouldn't write all those little ones. How I would usually write this would just be like this. I'd say 1, 2, 3, 4, and 5 divided by 1, 2, 3. And I would just say, those cancel, those cancel, those cancel, and I'm left with just that. Does that make sense?
But what about symbols?
Well, the nice thing is when you multiply by 1, what happens?
You're gonna get 3.
It doesn't change. So do I need to write that?
No.
No. So usually we would just write it like that. Now again, what does it then look like the rule is for division of powers? When we divide powers, what's it look like we can do here? You can cancel. You can write it all out and cancel. Absolutely. Do I need to do that, or could I have looked at these numbers and intuited this?
Divided by the powers divided by each other.
Yeah. Because if you look here, this is saying multiply by 3 how many times?
5.
And then it's saying divide by 3, because it's on the bottom of a fraction, how many times?
3.
3. And if we multiply it by itself 5 times, and then divide 3 of those away, what are we left with? 2 of them. Because remember, dividing and multiplying are opposite operations. Cancel each other. So what could I have done with these numbers, 5 and 3? What am I going to write as the rule, do you suppose? I can subtract. So we can say, if the bases are the same, fun fact about bases, there's a letter A in it. We can subtract exponents when dividing powers. let's do a real quick example here. Exempla gratia. What do we want? 2 to the 7 divided by 2 to the 5. I don't want to do 5 down there. I want to do 2 to the 7 divided by 2 to the 3. What's that going to give me? Somebody said it. Yeah, and how would you do that? I would say that must be 2 to the 7 minus 3. And 7 minus 3 is, as you've said, 4. So there's our example. Does the color coding help, or does it make it more confusing? I find it helps. But then again, I already know this, so it's really more important if you find it helpful. Sorry? A little bit? Okay. Now, I wish I'd saved this, but here we are. That's fine. We could end up in an interesting situation, which I guess this is as good a time as any to do it. What if I had 3 to the 5 divided by 3 to the 5? Can I do that? Sure. Well, first things first, you know that this is something divided by itself, so it has to equal... 0. No. Something divided by itself must equal... Okay, but listen, but you're on to something here. So here we say anything divided by itself equals 1, but also, what's another way we could have said this? We could have said 3 to the 5 divided by 3 to the 5. I could write that out as a full thing. 3 times 3 times 3 times 3 times 3 over 3 times 3 times 3 times 3 times 3. And again, we're going to see that cancels with that, giving us 1. 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 That cancels that, giving us 1. And 1 times 1 times 1 times 1 times 1 is 1. Cool. But here's the thing. And actually, I'm going to slide that over a wee bit. Give myself a little space. If we use our rule, what would it have given us? 3 to the 5 divided by 3 to the 5. If I use the rule, should be 3 to the exponent 5 minus 5, which is 3 to the exponent 0. And yet we know, what does this have to equal?
1.
Has to equal 1. So this gives us a new rule. Yay for new rules. Anything to the exponent 0 is equal to 1. Because anything to the exponent 0 really means divide this by itself. That's what the exponent 0 means. It means take this and divide it by itself, and when you take anything and divide it by itself, you get 1. But that's a really easy mistake, because if you just see something to the exponent 0, what's your instinct really quickly to be? Really? That's not my instinct. I mean, good for you. That's great. That'll serve you well. But when I see something to the exponent 0, what my brain tells me I want the answer to be is 0, right? Doesn't that feel natural? But you have to remember the rule here, which is that anything to the exponent 0 is actually equal to 1. And if you're ever forgetting why that's true, well, try it out. Say, how could I get something to the exponent 0? Well, I could have the same exponent on the top and the bottom of a fraction. That would give me an exponent of 0, but that would mean dividing something by itself. And when we divide something by itself, we get 1. All right, that's a lot. That's a lot. Does that feel like a lot? A little bit, right? Okay, let's try one of these together. And then I'm going to have you try the rest on your own. So here we have 2 to the 12 divided by 2 to the 8. I'm not going to draw that out in full because I have no interest in drawing 12 2's and 8 2's. No, thank you. So how would I write this as a single exponent? Well, it should be 2 to what exponent? Sure, how'd you do that, though? It says multiply 2 by itself 12 times, but then divide away how many of those? Divide away 8 of them. And if we multiply it by itself 12 times, and then divide away 8 of them. What are we left with? 2 to the exponent. Very good. Guys, you're doing great. That's really good. Try the rest of these. See what you get. There's a couple tricky ones in here. All right, a couple sneaky ones. I have faith in you. And I'm going to come around and say encouraging stuff like, wow, that's great. Or you suck. No, I would never say that. I would never even think that. No, absolutely not. Listen, I do a lot of things. I don't lie. I don't need to.
Mr. Orlando, are you ever going to give out those great job stickers?
Yeah, when you do a great job. Haven't we been through this?
I did a great job at French class.
Okay, I'm not your French teacher.
I'm doing a great job.
I should give other teachers my great job stickers with my face on them.
They should make ones with their face on.
I found these in my desk here. Yeah. So they're ready and waiting. No, you gotta do a great job first. Haven't we been through this?
Am I not
I'm
doing
gonna
a
work
great
hard
job?
just for that sticker.
There you go.
Am I not doing a great job?
Yeah.
Let's go.
I love stickers. Big sticker fan.
You should make them as buttons.
I want to make these into buttons. I think I'm gonna do like a limited run of like.
Pins.
I'm gonna do like 20 buttons every.
Like,
Yeah, like that. I think I'm gonna do that for film club every month. And anyone who makes it to like all 5 of the movies this month, I'll give them a button. Isn't that fun?
wait,
You should come to film
The
club.
Shining's terrifying. I haven't even seen it.
Yeah, absolutely. Yeah. Sorry? No, absolutely not. First of all, I like, as it is, I don't even drive myself home. My niece drives me home because she's an agri-college student and we carpool every day. So I'm stranded here until she comes and picks me up every day.
I have to take the bus.
Be a long walk for me. I live in St. Catharines.
What?
You live in
Be a
St.
long walk.
Catharines?
Yeah.
I live 5 minutes.
So does my mom.
I live half an hour away.
I like St. Catharines. I like Welland. I grew up in Niagara Falls. I like Niagara Falls.
I live in the country.
Where do you live?
I live 5 minutes away, but my dad lives in the country, I think.
Like a,
I don't even know where.
because I like my high school years. I lived out on Ridge Road, like right behind, like on the other side of the train tracks. Like super boonies. I like this. Yeah, what's up? I have a snack. Yeah, but I want to see 2 more of these guys. Okay? Yeah, what's up? The problem is telling you to do 2 things. The multiplication means you have to do what with those? So on the previous page, yep. And then the division means we need to do what with that number? Cool. So can you add those and then subtract that? Yeah, you got it. Let's wait a minute. I want people to look their way through the yes. Oh well. I'm losing my voice. And I'm trying to just push through it and talk. I don't feel sick really anymore, but I'm clearly losing my voice. And I'm just
And you hear
what I need is a day where I don't talk.
of 0.
I'm sure all of you would appreciate that too. Here we are.
Are they here? I see them. I see them also. Ask him that.
So like,
These were the stickers. Oh my god, my phone. These were the stickers. These aren't stickers though. I threw mine in the garbage.
that's cool.
Threw it in the garbage. She made it in the garbage. And she was sitting like here in the garbage. Good at basketball. Too bad I'm short.
You don't have to.
Look at my cat.
Twos instead of 1.
Good job to your cat. Can I meet this cat?
Yeah, you don't want to meet my cat.
I'm a scholar.
Yours is worse.
So you can't ignore the brackets and still
I have like my scratches right now. I also scratched my website.
You can do things. You can multiply the
He'll feed you.
much easier.
I know. Are you feeding your cat?
Yeah, I'm feeding him every day. He costs more than my dog. Yeah, I know. That's what I planned. Yes. I don't really care.
Yeah, it's guys scare me.
I think you'll die before me.
It's always going to
Oh, really?
Most of the people in my family live for a long time.
Take some practice. All right, let's take a look. Shh. Whoa. Okay, quiet down. You. And you. Shh. Thank you. One day when we have more time. Well, anyway, not today. Okay. 3 to the 10 divided by 3 to the 9. How do I approach this? This will leave me with what? Equals 3 to the 10 minus 9. And 10 minus 9 is 1. In other words, is there a better way to write 3 to the 1? 3. Cool. So if you multiply 3 by itself 10 times and then divide by itself 9 times, you end up with 3. Yeah. You may. All right, what am I going to get for this one? This will be 5 to the exponent. And how'd you do that?
122 minus 120.
Very good. Very good. What about this one? Now this is confusing. Sorry? Yeah, and let's get in the habit of saying like 4 to the power of or 4 to the exponent of 7. Otherwise, I'd just be like 4 7, and that's not what you mean, right?
47.
Very good. And how'd you do that?
First, I added 6 and 4 over the top,
Yep.
and then I subtracted 3.
Very good. That's right. This is just giving you multiple instructions, saying multiply by itself 6 times, then multiply by itself 4 more times, and then divide by it 3 times. There's no reason you can't do 3 of them at once. 4 to the 6 plus 4 minus 3, and indeed, that is 4 to the power of 7. Very good. I hate that 7. I loathe it. I still don't love it, but it's better. We're going to go with it. Better. Still not, I'm not having a great 7 day. Still don't love it, but we'll move on. All right. I don't know if that's how I was taught. People always make fun of my A's too because I make them like this. I don't know what to tell you. It's just...
What is that?
It's an A. What do you want? A, B, C, D, E.
I like that.
I don't know what to tell you. This is how I learned.
Why?
You're playing a
I don't know why. Why? Like, why? What do you mean, why?
Teacher teach you that.
Because that's... I got news for you. Like, type a letter A on your computer and look what it looks like. Oh, exactly how I draw it. Oh, imagine that. Oh.
Yeah, but nobody actually writes it like that.
Whoa. Oh, look at me. I like to do that. Well, I like to do this. I don't know what to tell you. It's how I was taught.
You're not playing Hangman.
Anyway. Here I have a letter. Does that intimidate us?
Yes.
No. What would we put?
T to the power of 7.
Which, how'd you do?
12 and minus 5.
Very good. You're probably going to make fun of that there too, but again.
Or an upside down 7. See, look, it has 7. That 7 looks normal.
Wow.
It's an upside down 7.
All right. And then now putting 2 things together, working with a letter, working with multiplication and division. We're good. What should this be? Give me the steps first, then the answer. Yeah.
3 plus 5
Yep.
minus 4.
Very good, because we're multiplying it by itself 3 times, then 5 more times. Then we're dividing away 4 of them. And that should give me n to the exponent. Very good. Well done. Guys, that was really good. I think you're doing great. If this is confusing to you, that's okay. Like, it takes some time. I think you're doing, as near as I could tell walking around, I think you're doing a great job, but this takes some practice, to be sure. Does anyone have any questions about any of these? Don't be shy. All right. We're going to do one more thing. Is that true? Yeah, that's true. All right, we're going to do one more thing. Oh no, what's this?
Painful to my eyes. Brackets.
Oh man, this is a power, and in this power, we have 7 as the base. And what's the exponent? 3 is the exponent. Cool. But we actually have a second power here, which is the big one. And for the big power, we have 7 to the 3, and that whole thing is the base. And then what's the exponent? 2. This is a case that we call a power to a power. It's kind of ugly, isn't it? Yeah, it's not nice to work with. So let's talk about what it really means. What does 7 to the exponent 3 mean? 7 times 7 times 7. But then what does it mean to square something? Well, just in general, what does it mean to square something? By itself. So in this case, what are we multiplying by itself? 7 times 7 times 7. Very good.
7 times 7 times 7. No, the other one.
Oh, thank you. Sorry about that. And you're right. If I wanted to, could I put these in brackets? Yeah. Because in math, what's the default operation? Multiplication. Cool. Altogether, how many is this?
6.
7 to the exponent. 6. 1, 2, 3, 4, 5, 6. All right. So what's the rule? Did we add here?
No, wait, never mind.
And what do we do? Very good. And what do we do to the base? Yeah, leave the base alone. Which I know we've done in every case, but here it's worth keeping in mind. When we have a power to a power, and I'm going to put just an example here, just so we know what we're talking about. Like 3 to the 8 cubed. We multiply the exponents. And don't change the base. And maybe I should have mentioned in the previous 2 rules that we don't change the base, but I'm mentioning it here. Because here I feel like it would be natural to want to change the base. But we're not going to change the base. And again, when in doubt, draw it out, right? If you draw this out, it makes sense.
I find this joke so funny.
I don't really know what the joke was, but...
The way you said it.
When in doubt, draw it out.
Oh, well, that's not really, I suppose it rhymes, which I wasn't really planning. I gotta say, it sounds better with your very convincing English accent. I've gotta say, does this just feel like you've traveled back over the pond, England all over again?
I'm not jumping on tables now. I'll jump on a table.
Wow, guys. Okay, let's try the first one here together. How would I write this? We have, what is the power here? The overall base is what? 2. And then we're saying to the power of 3, but then we need to do that how many times? Twice. For a total of 2 to the exponent? 6. And if we wanted to see it drawn out, that would be 2 times 2 times 2 times 2 times 2 times 2. Right? All right. Try these out. And by the way, I threw a miserable one here. Oh, sorry. Ooh, I didn't realize it wasn't going to be hard for you. Now I know. So see if you can figure it out.
Do you think you can just go up just a tiny bit?
Yes, I'm sorry. How is that? Can we see that?
Yes.
All right. I'm plagued by my lack of battery charge here. I'm regretting not having plugged it in last night when I got home. Do you know why I didn't plug it in when I got home?
No.
My puppy ate my charging cord. Just ate it completely. It's just destroyed. So I had to order a new one.
Good, huh?
Just dug into that thing.
Did you call the cats that got this?
Yeah, the dogs aren't godless killing machines. They're just dumb. My dog is a little bit stupid.
Dogs will eat everything.
Yeah. Also stupid. See, I never think of cats as stupid. I always think of cats as like maybe a little too smart. You know?
When we first got him, we kept under a wall.
Okay, so maybe your cat's dumb. Your cat might be the exception. What's his name?
Stash.
I like that.
He's a mustache. My cat has a really long tail. Did I show you the picture? No. His tail is longer than his body. She looks like a weird tail.
But like, don't be fooled. These are being multiplied. Your multiplied numbers. Whoa!
Hey, oh my cat.
I get to work.
I did my work.
It's literally
What is this?
P equals 3 plus 2. Nope, times 4. It's times 4 here, you're adding them. No, you're multiplying them. Are you okay? 3 times 2 is 6. 3 plus 2 is 5. Are you okay? Yeah.
Something in the corner of my eye, I look at it and
What is this?
oh no, if I stare at it, I can see like
Yeah, I just don't know my time.
every time it's not like life is you, it goes through a 99 second.
All right, if you're feeling confident, come put one up. Neatly, might I add. Neatly. So sad right now.
No, you're doing the one that I want to do.
I'm rounding. You're rounding. What is rounding?
I just ripped my slime.
Oh no.
Okay. Yeah, really do it, but.
Why are my favorite math teachers?
So you need like the kind of this. Okay, let's see if I can do this without breaking the neck. You just gotta like bend that thing. There you go. There we go. we still got 2 up here, team. What's going on?
The other way.
Yeah, I got it on that.
Why is your mind on the floor? Because I don't want to just put it here. Why is my writing on there?
I don't want it. I don't want it.
All right, listen up. Shh. Shh. Thank you. Well, that worked better than I expected. Oh. Thank you. Okay, let's take a look. So the first one, we power to a power 2 to the 3 all squared. We said that's 3 times 2 to the 6. Great. Here, same thing. 5 squared all to the power of 3. We got to multiply those because that says multiply 5 by itself twice and then do that whole thing 3 times. So 2 times, 2 times, 2 times. That's 6 times. Now here, lovely job. 10 to the power of 2, 6 times is 2 times 6, which is what, by the way?
12.
So that's going to give us 12. And then here we have minus 4 to the 3. And what's that going to give us?
12.
And what's 12 minus 12? 0. And anything to the exponent 0 is?
1.
This was lovely. Nicely done, whoever did that.
You're welcome.
Go Carter.
Didn't say thank you. I said well done, but okay. I'll take it. Now, for some reason, nobody opted to do this one. I think this one's pretty easy. What does this say? I will.
Looking at the harder pages.
Okay, and how'd you do that? Good. Because this says multiply r by itself 5 times, but then it says do that whole thing twice. And that gives us r to the power of 10. Lovely. Great job. This one, same thing. S to the power of 4 times 3 gives us s to the 12. Lovely. This one here is done perfectly, though there's something that jumps out at me that we got to watch out for. Not a big deal. So first of all, is this p to the exponent 20? Yeah, I like the answer. The answer is great. Good job. There's a little bit of the formatting here that stresses me out. What stresses me out a bit in this formatting? Yeah, we have to remember that if we want to say add first and then multiply in math, there's something we have to do to say that. Yeah, we got to put it in brackets. So just remember that. I'm going to rewrite that. And again, I don't mean this as a criticism. You guys did a lovely job. But just remember that this here is that. And then we need to multiply it by 4. But we need to tell the person doing this work that we want them to add and then multiply. And in math, normally, what do we do first? Adding or multiplying? Multiplying, that's our default, because it's our default operation, right? So if we want to say, actually, I need you to add first, we need to provide some kind of instruction for that. And in math, the way we provide that instruction is we put those inside brackets. But again, I don't want that to sound like a criticism. You got the right answer, you did a lovely job. Just a question of formatting, how we write things. Does that make sense? Okay, now if you look here, there's a bunch of practice here. Some of this practice is easy. Some of this practice is tricky. Look at me. I want you to try it all. I want you to try the easy practice. Hopefully you'll get it. If you don't, that's okay. We'll work on it tomorrow. I want you to try the tricky practice. Probably you'll struggle with a few of them. That's okay. That's good. I think it's so easy to get afraid of challenging questions. You should like the challenging questions. They're good. And one of the ways we keep ourselves from being afraid of the challenging questions is we don't worry if we're wrong. Not even. We just know that every time we get a question wrong, we're learning something. And that's important.
Three minus 3 is? Okay. So that should be 7 to the power of 0. Which is what? Well, 7 to the power of 1 is 7.
I mean, I need to come together.
I think the right way, right? But you have to write 7 to the power of 0.
And that correct line goes
And
on
show
all?
that
And
7
then
I was alive.
Feet down
That same here. C to the power of 0 will be 2. The binary to the power of 0 is 1. Okay, so it's just a big
I don't think I can sing anything right now. Voice is not cooperating. That happened to me once. I had a Canada Day gig one year. I have a partner. She and I play, but I mostly, I sing lead and she mostly harmonizes. We got about 2 minutes in, and all of a sudden my voice just went. It was just gone. I just couldn't just air. Nothing came out, and it was awful. It was very stressful. We had like an hour still to play, and I just could not make my voice make any sound whatsoever. So we just had to totally rearrange things, and Tara had to sing everything, and I felt very bad for her. But it was the strangest feeling in the world. It didn't hurt or anything. It was just like all of a sudden my voice just was gone. Middle of a gig, yeah. Not a good feeling. And like as part of a lineup, like it was miserable. Because it was like a Canada Day gig at a big winery. So we were like right in the middle of a day of like 20 different musicians playing. And there I am up there like, that was not good. Very embarrassing. Oh yeah, of course. So guys, listen. I just want to stress this again. We're going to take this up tomorrow, but this is the kind of concept that you're going to have to practice a few times. I say this all the time, especially in like my science classes. Listen, look at me. If there was like some magic spell I could say and then like go, oh, and you guys would all know how to do this stuff, I'd do it. Like, cool, I'm on it. But like so many things in life, the only way you're going to get good at this is practicing. All right? You want to learn how to play the piano? You're going to have to practice. You can watch someone play the piano until your eyes hurt. It's not going to make a difference. All right? You got to learn it. You got to practice it. You can practice. You can watch somebody, do volleyball serves overhand all day. All day. It's not going to make you good at it. Not unless you sit down and do it. I'll stand up and do it. The last page is all right, but yep. That's fine. Nice. That's fine. I'll make Jonesy do it in the afternoon.
You're not doing it all. Right now, I'm really energetic for a minute, and then I'm tired.
If you don't see an exponent, what is the exponent? Next, and when we divide in powers, what do we do with those exponents?
So what
Yep.
Okay, so it's correct here, but there's no other exponents.
So what are you actually doing there? This looks like, at first glance, power of power, but really, if you have two things next to each other, what would you like to do with them? So that one's being sneaky. Once you think it's power of power, yep. Well, no, you're doing x to the 4 times x to the 5. You're doing multiply 2 powers when you get the exponents. So this is actually saying the exact same thing. Right? So what do you do with powers when you multiply? What's the rule for multiplying powers?
Oh, yeah.
Basics stay the same. What do we do with the exponents? So that would be x to the exponent. You're right. If I want to write it as an exponent, alright, so guys, that's homework. Make sure you get it done. You, telephone. Yes, I'm gonna keep it. I can do whatever I want. I absolutely can do that. I can keep it for life. I don't keep it for the day. Right? I'm going to. I'd love to see it. Oh, I love that. Yes, here it is.
I suppose I'm back up with me. Oh God, what's wrong with me? Okay, so I'm just gonna go through these, and you're gonna say yes, I have it, or no, I need it. Okay? Bye, guys. So you were here for yesterday's appreciation note, I think, right? Yeah. No. Were you here for this one?
Yeah.
Yeah.
Yeah. Okay. What about this one? Cool. And then what about this guy? Yeah, check that one.
Break them before you.
It's not
Okay, well, stop on any time. Yes, I have that one.
Oh, good. Okay. What about this guy? Cool. If you put your binder up here, I can look. All right. Yes, absolutely. So it's just 1.3 and 1.2. And 1.2 wasn't even. So it's 1.3. And then I'm trying to remember, you got me assignment 1, I think, assignment 1.1? I think you did it. I think you're in my grade book. I'll double check. Okay, so we're going to print this to copier 1. Hey guys, how we doing? Wunderschön. How was your morning?
It was a morning.
What do you have in the morning?
I have English and then math.
English, then math. And what's your period 2? History. That's right. I knew that. Mr. Bowtie Man. I'm going to tell veterinaries Mr. Bowtie Man. I like that. So did you get this one here? I think you did.
No, I don't have that.
Okay, so this, don't worry about being late. That's fine. We'll get that to you. Can you quickly remind me your last name? I'm sorry.
Miller.
Again?
Miller.
That's right. I knew that. I'm sorry. I swear I'm working on it. And there's 2 of you. Like, now, are you related?
No.
No.
Not at all.
Not at all.
No.
So this is the same last name. Isn't that interesting? There's a whole second Orlando family in Welland. And it sounds like they're really nice people, because every time I run into someone, they're like, "Oh, are you related?" And I'm like, "No, I'm not related to Mike Orlando. Never heard of him." So here we go. 1.1, yes. Miller. And yeah, there you are. And that looks good. So we'll go get these. I'm printing them both on the first copier. And then if you need help with any of them, you just let me know, okay? All right, cool. We'll go together.
Going? Good, how are you? Is Orlando gonna be in here? Yeah. Or is he out for work? He's here today, I don't know if he's out for lunch or. I'll be out here for lunch.
It's your Orlando versus.
I don't know if, like, he's here today for sure, I just don't know where he is at this.
I will begin my
Check the
search.
math room across the hall.
Oh, really?
Hi, crew. All right.
You got him, found him? You tracked him down?
No, we kind of met halfway.
Oh, one second. I gotta find Patrick's test here, which you will find in my incredibly neat and organized desk. Which I need to get neat and organized this period before I have an attack. You all done?
Well, I didn't do a section because I was confused.
Sit down.
Do it. Okay.
Yeah, we're not doing that.
I've got my own test.
Yes, not Patrick's, but yes, I do. I need to deal with that one too.
Yesterday? It was yesterday. We watched classic movies. We watched The Little Man.
Wait, there's one yesterday.
It's on Monday, so we're there before.
Every Monday. Except when it's Tuesday. It's gonna be good. Alright.
I wasn't happy about this.
Yeah, you were. You did.
Alright, listen.
It's my
We're doing this a little bit different now.
yeah.
You can get your notebooks out if you want. Those are easy. If you need help with questions,
I'm
don't
not
skip
seeing
it.
my routine.
Alright? Cool. Grab your notes. You're good to go.
Maybe on my list.
I'm not. No. It's the same.
Yeah, what's up?
What's this?
Okay, cool. Come with me.
What's this?
Okay. Covalent compounds. We've got carbon and silicon. We've got nitrogen and phosphorus. We've got oxygen and sulfur. Then we've got chlorine, chlorine, bromine, iodine. Alright. How many bonds does carbon want to make? Get to a full shell. We get through it. Yeah, go. How are we doing?
What are you looking for?
You're taking forever.
Wow. Take forever. I'm going to be here for a little.
Yeah, go take a look at it. You can see it there, and then I'll show you the software and such in a moment.
How much more?
How many bonds does carbon want to make? Yeah, good, because it's got 4 electrons in its outer shell. It's going to need to pair up every one of those, right? But silicon. Yeah, good. Whereas nitrogen, how many bonds is it going to make? Good, so it's got 5 electrons in its outer shell. It's going to use 3 of those to make bonds, and 2 of them are going to stay solo, right? What about phosphorus? Same, right? And then what about sulfur?
You are my
And
friend.
Good, because it's got 6 electrons in its outer shell, right? So it's going to leave 4 of those alone. It's going to use 2 of them to make bonds. What about oxygen? Same, right? It's got 4 electrons that are just solo, and 2 of them are going to make bonds. The fluorine, bromine, iodine, acetylene. 1 bond, and the rest just fly solo, right? Because it's got 7 electrons. 6 of them will just chill, 1 of them will make a bond. Does that make sense? So when you go to make an ionic compound, or a covalent compound, which is sharing like this, you can make anything you want. But the only thing you need to know is that if you use carbon, how many bonds is it going to make? Cool. If you use sulfur, how many bonds is it going to make? But if I use hydrogen, not up here, where's hydrogen? This is kind of a weirdo, right? Because it's not way over here, but keep in mind, hydrogen looks like this. It has only 1 electron. It shouldn't be able to share at all, should it? Didn't we say you have to share your way to a full shell? Except, what's a full shell for hydrogen? Look at the table. How many electrons fit in that shell? Only 2. So hydrogen can actually make a sharing bond and make a stable compound. So anything you draw, so after that, the sky's the limit. We said it's like Lego. You can build whatever you want. I could go, there's silicone, and I'm going to put another silicon here, and I'm going to put nitrogen here, and I'm going to make 2 bonds to oxygen. I'm going to put an oxygen here, which is going to bind to a hydrogen, and then I'm going to make this into a double bond, and then I'm going to put a hydrogen here, and a hydrogen there. And that's fine. It's made it up, right? And the only rule is, how many bonds does every silicon have to make? So let's see. This one's making. How about this one? Cool. How many bonds does every oxygen have to be making? This one's making. This one's making.
How many bonds does every hydrogen have to make? Makes sense. Again, covalent compounds are complex. You can make an infinite number of different things. There's no right or wrong answer. Well, there's no right answer, and an answer is only wrong if it doesn't follow the rules. Is that comfortable? So what have you been asked to make here? 3 different compounds of nitrogen and hydrogen. Okay, I'm not going to do that. So let's say I want to make 3 different compounds of sulfur and chlorine. Well, I can have sulfur. It wants to make how many bonds? Sulfur.
Oh, 2, sorry.
And I can put a fluorine here and a fluorine there. And does that get the job done? Sure, right? That's allowed. But what if I did this? Does that get the job done? Yeah, sure. This sulfur is making, this sulfur is making, this fluorine's making, this fluorine's making. And this is going to get boring. The sulfur isn't really, with only 2 bonds to make, all you can really do with it is make a chain, right? So this is going to be boring, but I could say sulfur, 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 fluorine, fluorine. You know what I mean? Sulfur isn't quite complicated enough to give you very interesting shapes and structures, which is why sulfur isn't the molecule, the atom that forms the chain and forms the basis of most life. What is the atom that makes the base for most life? Carbon. And why does carbon make sense? She makes 4 bonds. Right here, all I can make is just a chain that's going to get longer and longer. Right? Sulfur just makes 2 bonds, so left and right, go, go, go. Carbon makes 4. You can make all
Can I have Mr. Matola to the main office?
Does that make sense? Cool, get on. Gotta leave it blank. I'll fight you. No? Oh. Qu'est-ce que c'est?
Oh, it's for lab testing macromolecules.
Nice, love it.
Do we have scales? Well, sorry, I know we have scales.
Yep, though we have a missing scale right now, so check in your room. I'm curious if Trush had it. I don't know where.
I haven't seen it in there, but I'll take a look tomorrow.
Yeah, they are in a dismal state of repair. That's one of this year's big budget spendings I want to get. The analytical scale in there, it stays in there.
Yeah.
But all the other ones here are fair game. And we have a decent number of like.
Do we have like 5 or 6 that work?
No. So you guys have a range. These 2 are in great working order. This one's in great working order. And then all the others are currently, we have 3 more that are not playing together. Unfortunately, and like, which is why, like, these of all things, just make sure when you're done they get back in here, because they do seem to A, grow legs, or B,
Fingers. That's the best way to make my nose just taste
Anyway, unfortunately, right now, this is the only one that gives us milligram or like 100 milligram precision, so like 1 decimal place. These are both nearest gram. It's trash. Yeah, because both of our 100 milligram one or 10 milligram ones rather, one is out for repair and has, like, we sent it in, and has been since God knows when. The other one.
Can I have the following students to the main office? Hunter Cote, Jack Mallet, Brandon Lundberg. Thank
You
you.
can see why that's going to be this year's focus. But when it's this year's focus, I got to figure out a good, better. Might even actually make it purple. So it's not being out for equipment. Just kind of, just add a little bit of traceability, so it's like we can know where they are.
My dad's
Those
going
are
to
yours.
surgery.
For sure, I'm gonna have them back in there. And then if you really do need some precision, then more than welcome to use that.
It's just conservation stuff. That'll be fine.
Yeah. Cool. All right. What lab do you do for that?
I think tomorrow I'm gonna do baking soda and vinegar in a flask with a lid over the top.
Nice.
I can't like walk alone. Like I want to walk.
Yeah, great. So I'm doing 2 labs and no prep, and it's
Do you
fine.
need any help in that? Do you need something brushed up? I can do it.
No, I wanted to have lunch. But
Sure.
It's all good.
Listen, text. Let me know if you need something in the setup. Yeah,
I don't have period 3.
yeah, I'm all good now, but my period 2s were fun. Alright, thank you.
Think you have to borrow this from you for period
Yeah, no problem. That was pretty good today. They actually pushed it up pretty well.
What? I don't know.
Good work. The work was pretty good. It's funny how that goes.
I don't know.
You can take the beginning gap on any given day.
But they were like, it smells bland.
And it's funny, you need some boring topic.
Oh, let me tell you.
Yeah, and I feel like two structures for success.
They were so good.
Make
Because I ate like so They were so good. They were like wrapped. They were like croissants.
I like that. I feel like especially now in pastry, so it's easy for kids to just sit down and I know I gotta start.
Anyway, kind of going inside.
Well, I'll show you. You do it by yourself. And we have watch. Right? Watch, do independently, apply.
And then I always
Yeah, exactly.
So I'm never gonna.
Alright, so
I shall see you, well, I will yes, day anyway, so.
let's go and take a look. So I've got here, I've got two 3D printers. I think.
I know.
They're so like.
Right? And it is much higher resolution. Obviously, but this is actually super cool. Photosensitive resin. So as you
When I did like write a short story in English, and my aunt had this one story where she didn't do the story. She was like talking about her
this guy, which is what you have to use for bigger stuff.
and like, how should I do it? And I was like,
I got to replace the nozzle in extruder 1, if my memory is serving me well. But extruder 2 is in good working shape right now, so that's a dual extruder, which means you can actually have it kind of building out of two different materials, or if you have a part where you need like 2 copies of the same part, or maybe like mirrors of the same part, you can actually have it building both parts at the same time, which is really cool. Yeah.
And also, like, the chess pieces are not all that big either. They can come in their separate pieces.
Damn thing. Gotta replace this cable. I know.
Coming in the back there, I was like, this looks like Ghostbuster equipment.
I hate you so much. Hello. There we go.
He wants us to get this. I think you're the only teacher I've seen so far with a light up.
Brody Grata to the main office. Brody Grata to the main office.
Oh, I hate you so much. The cable for my dock is in rough shape. So I need to replace it, but until I replace it, I need it to just stop being a pain in my butt. So now I should actually just. Rather than continually.
You could like a I think it's pretty cool.
Alright, so let's just do this so I don't keep screwing that up. Dongle into a dongle into the card. What could be better?
I just realized, Con, your phone is so small. Well, I like small phones. See, Orlando, when we talk about DeLorean armor, I want to look at making it like that.
Cool. So I'll show